So hi, I'm Jason Cotrell, founder and CEO of Rcam Technologies. I'll speak just a bit about Rcam halfway through the presentation, but let's just jump right into this. So I'll be speaking about some of the trends in the wind energy marketplace and some of the things we might be seeing and are seeing in the future. So first and foremost, as Dan mentioned, you'll see this more and more, but wind and solar are forming the backbone of the energy transition, as many people are beginning to refer to it as. And that's because of, one, their low cost, and also their very low carbon footprint. Wind in particular is one of the, if not the lowest forms of new lowest carbon forms of electricity you can find. So if you're going to speak about offshore wind, it's very important that you understand what has occurred in Europe and what continues to occur in Europe over the past 20 years or so. So Europe has been leading the way, especially in the UK. The UK, what's shown here on the right are the, in green are the amount of megawatts of wind energy installed. And then what you see in orange and red are the planned installation and the size of the bubble. The largest bubble is 2.4 gigawatts. So UK presently has about 10 gigawatts installed. They have 4 under construction, and they're planning another 23, 24 gigawatts by 2030 in the next year. And by 2050 becomes even more ambitious. They're targeting 100 gigawatts, which will bring the UK to net zero carbon. And this is, of course, a big business opportunity. Every gigawatt is equivalent to approximately $3 billion of CapEx. So if you're talking 30 gigawatts, it's a very large number. Okay, so looking towards the US, we, especially in the last 2 years, have really hit the gas. Even within the past 2 weeks, the presidential administration has announced the plans to develop 7 new offshore lease sales by 2025. And so what that basically means is that there will be wind on effectively every coastlines of the continental United States. Okay, so that's a high-level view of the marketplace. What are we expecting in terms of the technologies that we need to get there? So first of all, the size of the turbine in offshore wind is the most important lever in influencing and reducing the cost of electricity. And so accordingly, we have seen the size as shown here in the plot and the data points, both in the operating in white and the announced plans in blue, grow. I don't know what the power of this function is, but parabolically over the past years. We're presently, they're making announcements for installations with 15 megawatt turbines, and most expect that we will certainly see 20. And there's even some rumblings of 25, 27 megawatt potential sites in the foreseeable future, perhaps. So this is very important for concrete because it also means these are huge turbines. A 15 megawatt turbine or a 20 megawatt turbine will have a rotor diameter of 250 meters. So that's 1/4 kilometer. Giant machines. And concrete scalability plays very well in that dynamic. So the other very important factor is that the depth of installations of offshore turbines is also increasing, perhaps more linearly, but it's another factor of scale that's very important. Now, these are all fixed bottom machines, and I think, well, I don't want to quote statistics that I haven't updated recently, but by far, almost all machines are on fixed bottom installations, foundations, which basically mean they're attached to the seafloor. That will be changing over time. But for now, those machines are installed in depths up to, well, you can see there's some larger ones announced, but in general, 50 to 60 meters is kind of considered a transitional depth. But the key here is that they're getting deeper as the technologies improve and the need to reach new resources improves. So speaking about deeper waters, what you will also hear is that the future belongs to floating. And I would say, yes, I agree with that. But when will the future belong to floating? Because right now, and that statistic just keeps coming up, something like 99% of all installations are fixed bottom. So we will certainly see things change. And what you see here, it's a matter of cost. What you see here are different cost estimates and basically for floating wind. And just to make sure everyone's on the same page, so floating wind is a floating substructure on the top of the surface that is moored to the seafloor. And the reason you do that is for deeper waters. So floating turbines fit in the range of maybe the shallowest has been about 35 meters, and the deepest ones can be on the order of hundreds of meters water depths. And the reason they say it belong, one of the reasons why is something like 60% of all offshore wind resources are in waters too deep for fixed bottom. So what are these little diagrams that I've inserted here? So that is our fixed bottom solution in Rcam technologies. And what I've shown in each of these plots is where we have designed this foundation for, where it fits. And so these are the costs that we're looking at for our fixed bottom solution, and I superimpose that on the costs for floating to give you an idea of where we're at. Okay, so how, Rcam is a startup, we're a small company, we're expanding, we're growing internationally. We have an office in Colorado, California, and Scotland. How does this fit into these trillion-dollar markets? What role can we play? What are we doing? So in general, we try and have been successful in staying 2 to 5 years ahead of where the market is at and also market awareness. So we got started in using 3D printing technologies with concrete in about 2017, where we manufacture these foundations in the field. And then we've been able to apply and explore the use of these technologies for both fixed bottom foundations as shown here, and more recently for floating foundations as shown here. So we effectively exclusively work in concrete. We also have some products for energy storage and wave energy and even floating solar. So what might be coming? If our ideas are successful, this is what we envision. We envision that these concrete components, in this case, it's a fixed bottom turbine that's towed out, would be manufactured port side. And these red gantry systems are basically printers. And we envision that these will be printed in multiple shifts, port side, deployed into the water and towed out to sea. And this has got quite a bit of traction, in part because it's lean manufacturing, because you can do some things. There's no formwork, where you have durable, low CO2. You can use different concrete materials. But perhaps one of the biggest things and drivers of concrete are the good jobs, especially around port areas, which means disadvantaged communities. So it really fits and has gotten a lot of traction since we started. So if we zoom in and, okay, well, what's happening today? What have we been doing? If you're focusing on the U.S., you really have to look to the New York area and New England. That's where most of the activity has been. They're targeting basically 2,000 turbines or 30 gigawatts by 2030. But there's a number of challenges. One is the availability of the supply chain on the East Coast. the availability of American flagged vessels, which are required, and then the conventional solutions, which are monopiles. There's a monopile shown here, driven into the seafloor, are hammered in. And that creates noise, which has some environmental challenges that need to be mitigated. So we have this solution. I won't speak any more about it, other than I would encourage you to attend this free, this is the National Offshore Wind R&D Committee Symposium on November 8th. It will also be recorded if you want to learn more about this technology and go deeper. So we have recorded a 20-minute presentation there. With regards to, well, what is this 3D concrete printing? Is it science fiction or not? I assure you it's not science fiction. It is, all of these things are happening so fast. So this is in New Jersey. This is a 42-foot printer by Black Buffalo, who is backed by Hyundai, one of the Hyundai companies. And so there's a person there to give you a sense for scale. This is Florida. And basically, probably by the end of this year, there'll be at least 5 printers like this, if not 7. And I imagine a doubling of the number of these large-scale printers in the US. So we don't have to build the printer technology. It is coming. It's being developed for houses and bridges. And we're basically adapting that to offshore wind. You don't have to take my word for it. Shortly after we started working in towers, about 2 years later, GE and Lafarge and Cobot, a printer manufacturer, joined a group, a consortium that is basically developing a 3D concrete printed onshore wind tower base. So they're very invested in this technology. They're focusing on onshore wind, and if they can do it for onshore wind, I believe we can do it for offshore wind. We're also in the anchor space. Now, what is it about anchors? Why are we competitive there? What is it about concrete? That's what I'm trying to get to here. There's different anchor solutions. There's gravity, and concrete is great there. There's steel suction anchors. And then there's these drag anchors, which are also steel. And another challenge with anchors is the vessel availability. We have used concrete to come up and take the best features of all of these to provide an anchor solution. And what's interesting about anchors is that, it's kind of like a foundation. It is a foundation, so to speak. Every turbine of every configuration needs an anchor. So the market is huge. It's a beachhead market for us that we can develop these technologies for a broader expansion. And what is possible? So Scotland funded us to study the use of this technology. And this shows you what's possible for concrete suction anchors compared to steel. You're basically looking at a 75% cost reduction approximately compared to steel. Those are compelling numbers. Those are numbers that make sense and will allow, I believe, these technologies, whether they're 3D printed or cast or slip form, to make very substantial inroads into the offshore wind market. And then just a final slide. So, these are the things that came to mind quite quickly about, well, what's holding concrete back from getting to market in terms of fixed and floating concrete substructures. It does take about $100 million to bring a new foundation technology to market. They're heavy. They're around 10,000 tons. So port infrastructure and planning are key. And also the installation system of either for fixed and floating, this is also a concern. For anchors, this is an area where we really need help from ACI and its ecosystem. So new product risk, of course, the turbines that we're anchoring are $30 million. So whatever you're deploying, you want to make sure it works. So concrete marine durability, if you're focusing on 3D concrete printing, so the printing characterization and certification. And then, of course, there's all sorts of geotechnical suitability for different anchor solutions. And then on the West Coast, seismic liquefaction. So if there's an earthquake, what happens to your anchors? And then always, as always, in both onshore and offshore, access to places to install your riskier products on offshore wind turbines is still a challenge for us and I think others. So with that, thank you. If you know folks that want to work with us, please send them my way.
Thank you very much, Jason.